Hello, everyone, and welcome to another Directions Mag Geospatial webinar, today sponsored by our friends at Hexagon. I'm Barbary Duke, Managing Editor here at Directions Mag, joined by our webinar producer, Lynette Qualia. We are excited to learn more today from our friend Dean McCormick over at Hexagon. He has got some great information related to smart monitoring, in particular with wildfire mitigation. So welcome, Dean. We're excited to learn more about this great resource.
So thank you, Barbary, and of course, welcome everyone wherever you are. And thank you for attending this webinar. So I'm going to dive straight into my presentation. First, I thought it would be good to talk you through the agenda for today. So really starting off with what I intend to do is set the scene by focusing on some of the evidence that we are seeing for global warming, and in particular, its impact on wildfire activity. I then want to link some of the most destructive wildfires in living memory in the United States, and link those to electric utilities before highlighting some of the requirements the industry is having to consider to support and augment their wildfire mitigation programs. And then based on those requirements, I then want to introduce and demonstrate, and I'll use videos for this, how we at Hexagon are looking to leverage our geospatial technologies to address wildfire mitigation measures. I will then conclude with more detail regarding how the technology works, referencing some pilot studies before summarizing and opening up to Q&A. So without further ado, let me begin with at least the introduction. So the commonly held view, and really this is backed up by the science, the research and the data, such as that shown in this video, courtesy of NASA, is that the Earth is heating up. And what you're seeing is a color-coded time series analysis displaying a progression of changing global surface temperature anomalies. So normal temperatures in degrees Celsius are based on the average over the 30-year baseline period from 1951 to 1980. So higher than normal temperatures are shown in red, the lower than normal temperatures depicted in blue. So the final frame that you see here really represents the 5-year global temperature anomalies from 2015 to 2019. If we look further into the data, what it indicates is that globally, 2016 was the hottest year since records began way back in 1880, with 2019 being the second hottest. And the past 5 years, what we have seen is the warmest 5 years in the last 140 years. And the decade that just ended is the warmest decade on record, and every decade since the 1960s, in fact, has been warmer than the one before. So what the data is telling us is that the average global temperature is now more than 1 degree Celsius above that of the late 19th century. And in some areas of the world, such as the United States, we're seeing average temperatures increase by 2 degrees. And in particular, the state of California is showing an increase by as much as 3 degrees. So this rise in temperature may seem quite small, but its impact really has been felt across the world. So forests are remaining dry and getting drier for longer periods, with dry plants, trees, and shrubs really serving as abundant fuel for fires. And additionally, the warmer, drier conditions are also contributing to the spread of certain insects, such as the mountain pine beetle, which is commonly found in the US. And these can serve to weaken or kill trees, really building up the fuels, particularly in forested areas that are prone to wildfires. And so with these increases in fuel loads coupled with increasing temperatures, what we are seeing is an increase in wildfire activity in many parts of the world, particularly in the Western United States. And this is reflected in the data that you see here, which is based on research by NASA and the Rehabilitation Capability Convergence for Ecosystem Recovery Group, otherwise known as RECOVER, where they analyzed more than 40,000 fires from Colorado to California between 1950 to 2017, really to learn how wildfire frequency, size, location, and a few other traits have changed. And what the evidence is suggesting is that over the past 6 decades, there's been a real steady increase in the number of fires in the western United States. In fact, the majority of fires in this region, some 61%, have occurred since the year 2000. So what does this all mean? Well, this record of increased wildfire activity is clearly posing a growing threat to ecosystems, to people, to property, businesses, communities, and critical infrastructure. And because fire locations are becoming increasingly urbanized, the vulnerabilities as a consequence of fires can result in greater loss potential. I think given the extent of infrastructure linked to power companies, they are especially vulnerable to wildfires. Now we know there are many causes of wildfire, and these can range from discarded cigarettes, arson, and natural phenomenon like lightning strikes. But in recent years, some of the most devastating wildfires around the world, including those in California, as well as Australia, have been linked to electric utilities. And here's an interesting fact, in that at least 10% of wildfires in California, which effectively translates to around 400 per year, have been caused by sparks from transmission lines which have ignited dry vegetation, triggering some of the most devastating fires on record. And so to date, there have been some 13 historical billion-dollar lost wildfire events, 6 of which occurred in 2017 and 2018. We're not at the end of the 2020 wildfire season, and it'll be interesting to see if there are any more added to that list. But really topping the current list is the Camp Fire in 2018, which destroyed the town of Paradise in California. And in terms of impact, well, I guess the numbers really speak for themselves here. 64,000 hectares burnt, nearly 19,000 structures razed to the ground, 88 lives, one life too many, really, that were lost, and approximately $12 billion in damages. So really one of the consequences of electric utilities being found to be the cause of wildfires, especially where there is significant impact, is that it can lead to significant liability exposure. And in fact, California's largest electricity supply company, which caused the Camp Fire, was forced in January of 2019 to file for Chapter 11 bankruptcy protection. And having recently pleaded guilty this year, they are having to now pay an estimated $3.5 billion in settlement to resolve all insurance abrogation claims as a result of this fire. So that said, and I guess independent of the cause of the fire, maintaining a network's integrity is critical for electric utilities, really to ensure safe and uninterrupted power supply to communities. And fires clearly undermine integrity by destroying the equipment, the infrastructure, which supplies electricity to the communities. And this obviously impacts service delivery, which in turn impacts quality of service, which further impacts public relations, even more so if the utility is linked to the cause of the fire. The Camp Fire example has already highlighted the economic and financial consequences for utilities, especially where they are to blame. Additionally, the resultant outages as a consequence of fires, whether these are planned or unplanned, adds further to the economic cost owing to lost productivity for local community or economies rather served by the affected power utility. So I guess in the face of these challenges, the question really is, what do we see as being required by the industry? Well, clearly, there is a need to fortify the electric grid against the threat of wildfires and also to reduce the risk of outages. And how do we achieve this? Well, from our perspective, one way really is to take a more proactive approach to wildfire mitigation by addressing the following 3 key areas. So in the first instance, identification of high fire probability areas. Secondly, regular monitoring of vegetation condition changes. And thirdly, by incorporating integrated workflows for better vegetation management. So I'm going to talk you through these, each of these sequentially in a bit more detail. So in the first instance, this really means identifying and prioritizing high fire risk areas across the entire network. And once identified, utilities then need decision support tools to reduce customer impact, and as well as tools to help communicate with the public and coordinate with local, county, and state agencies. Secondly, and because of ever-changing conditions, both to vegetation, which we know acts as a fuel for fires, as well as variable weather conditions, wildfire risk associated with the entire transmission or distribution network requires regular seasonal monitoring. And so we believe by focusing on condition-based scheduling of vegetation management, as opposed to calendar-based scheduling, which is historically practiced by electric utilities, this can facilitate active liability management. Moreover, and through regular monitoring, historical data can be collected and referenced to assess vegetation growth cycles and as well as patterns and inform the effectiveness of vegetation management practices. And then finally, to ensure more active fire management, fire risk management rather, integrated workflows are needed to support business processes, really help manage field crews as well as to guide them with field data collection and updates. In cases where vegetation management is outsourced, which is fairly common, workflows can then be configured to task third parties to perform the necessary services. And so by achieving this, utilities are likely to be in a better position to improve their service delivery. This will obviously have a positive spin on in terms of public relations and importantly reduce the threat to people, to communities and critical infrastructure. And in so doing, helping to save cost and reduce the liability exposure. So the question is, what role can geospatial technologies play to achieve this? So firstly, what we are seeing today, this is really a comment, is an explosion in the use and application of sensor technology. And by this, I mean sensors that capture, record, and sense change about our dynamically changing Earth. And the derived data is being collected today with greater coverage, greater frequency, greater resolution, greater bit depth, like never before. And so for us, this really creates both a challenge and an opportunity. And the opportunity we see is really to fuse these disparate data sources to better model the dynamics associated with, for example, determining fire risk. The challenge we see is really a hyperconnectivity one. In other words, having platforms out there that can connect to multiple sensors, capturing different data in different formats, and then fusing, processing, and synthesizing the data to deliver value-added information products and services. And so in more recent times at Hexagon, we've really set out to meet this challenge by leveraging our years of collective geospatial IP and know-how. And this we've achieved through the development of a geospatial platform, which we call Map Enterprise. And it's through this platform that we have established what we call a smart monitoring framework, through which we can connect to practically any sensor, whether it be to collect traditional geospatial content, satellite imagery, IoT data, airborne data, unstructured data, and or weather data. And this data can then be fused through this platform and processed using our graphical spatial modeling engine with derived information products consumed and analyzed via custom configured applications. And these applications at Hexagon we commonly refer to as smart maps. So in essence, these are lightweight applications that deliver real-time and or near real-time dynamic information services to really better support decision-making, whether that be for monitoring for construction sites, flooding events, people encroachment into restricted areas, or to proactively monitor for wildfire risk. So now let's see the technology in action. And in particular, what I want to show you here is how we have configured our platform to support proactive monitoring of vegetation fire risk along servitudes otherwise known as right-of-ways of transmission and distribution lines for electric utilities. Please note that what I'm about to showcase does not represent different license products, but are applications that have been designed, built, and configured using this platform. So what you see here really is a smart map. And based on the most up-to-date information, teams responsible for vegetation management along right-of-ways can filter for high vegetation fire risk along those right-of-ways. The filter for different risk categories is represented by the pie chart widget in the top left corner. And you will note that based on the category selected, all other widgets dynamically update. Segments of right-of-way flagged as high risk then display in the map view. Additionally, additional filtering can be applied by selecting sections of the right-of-way corridor, which will then link to named supervisors responsible for vegetation management for the selected segments. You'll also note that additional information such as segment area, total biomass, as well as cleanup costs for the selected segment is presented and dynamically updated according to the segment selected. One can also look back historically in order to assess how the situation has changed, which can be useful to determine the success or otherwise of vegetation management practices. And lastly, the 3D views that you see here really help decision makers better assess the terrain and conditions on the ground, which can be useful to determine how accessible areas are. So these dashboards are simple yet highly effective decision support tools, which can really help to prioritize vegetation management practices. Prioritization is achieved by incorporating streamlined workflows such that managers assign supervisors responsibility for segments of right-of-way corridors, who in turn will then assign field crews under their watch to do the physical field inspection and or vegetation clearance and cleanup work. And all work completed can then be reported from the field by the field crew back to supervisors, up the chain of command to management, who then can certify the work back in the office. So the videos that will follow now showcase applications that are custom configured to support the different stages of the workflow for different users. So firstly, access to applications is based on role and responsibility and requires a secure login. What you see in this video is a configured, what we call rich client application, which really combines basic GIS functionality and workflows to support the needs of the manager. The manager sees a map view displaying the extent of the right-of-way. On the left-hand side, you can see an overview map, as well as a legend and layer control. At the top menu bar, there's a workflow button, which when selected displays a dialog box that you see here, which guides the manager through the steps of assigning new inspection jobs to supervisors. Managers can, for instance, provide a unique inspection job name, schedule according to a date, select the priority level, and finally assign the inspection job to a named supervisor. The last step is to use basic construction tools to demarcate the location and extent of the inspection site. Once the job is saved, it appears in the list of inspection jobs created. A notification is then received by the supervisor, who through a similar set of workflows will assign a field worker to do the physical inspection. So for the sake of time, I will not demonstrate this part of the workflow for the supervisor, but hopefully through this video that just demonstrated, managed to exemplify what that process could and might look like. So now let's look at the application and workflow configured for the field crew. So what you see here is a mobile app, which can run on Windows, Android, and iOS devices. When logged in, inspection jobs assigned by supervisors are visible in a list. Once a job is selected, a form will display with certain information already populated. Field crews can then collect additional information aided by pick lists, drop-down lists, scroll lists, etc. Of course, these forms are fully customizable. Additionally, users can use the device's camera to capture and save images. and all work can be undertaken in either a connected or disconnected mode, with synchronization back to the database occurring once a connection to the network is made or restored. What is not shown in the video, but which is supported, is things like geofencing, as well as navigation to assist field workers to finding their way to inspection sites. So, having now seen the technology in action, let me now focus on what is happening behind the scenes, paying particular attention to the fire risk algorithm. So in order to flag areas of highest vegetation fire risk probability along right-of-ways, we have worked together with a long-time Hexagon partner, Geodata Design. Geodata Design is a Cape Town-based company that specializes in the exploitation and analysis of satellite imagery. And so using our graphical spatial modeling engine, as depicted in the middle graphic here, Geodata Design has developed a fire risk algorithm called Prometeo, which can be set up as a geoprocessing service to support continuous fire risk monitoring. The end result is a display of sections of right-of-way represented by vegetation that are fire risk prioritized from lowest, medium to highest risk. The red pixels in the graphic on the end really represent areas of highest risk probability. So in essence, what we have done is we've integrated the Prometeo algorithm into our smart monitoring framework. The algorithm itself is dependent on a number of data inputs derived from different sensor types, including weather data, satellite imagery, topographic data, and finally, proximity data. So weather conditions are modeled according to the Canadian Fire Weather Index model, and requires measurements such as precipitation, temperature, wind speed, and humidity. And these are taken typically at each day at the same time, typically around noon local time. The end result is an indication of dryness as well as fire danger levels. The vegetation conditions are modeled based on Sentinel-2 satellite imagery at 10-meter resolution. And this imagery is made available by the Copernicus program operated by the European Space Agency. The beauty of this imagery is that it's free. It covers wide areas, including transmission and distribution networks spanning hundreds, if not thousands of kilometers, and has a regular refresh rate of typically anywhere from 5 to 12 days, depending on where you are in the world. This makes it very useful for regular and continuous monitoring, especially during wildfire seasons. And besides weather and vegetation conditions, the algorithm also considers topography. In other words, slope and aspect, as well as elevation, since these really influence both the potential and spread of a fire. Noting, for example, fires tend to move uphill rather than downhill. Additionally, proximity to human settlements is also factored in, since these are areas with high potential to cause fires. By fusing these disparate data sources and processing via the algorithm, sections along right-of-way with vegetation that is deemed to be high fire risk can be flagged. This can then assist decision makers to prioritize vegetation management according to existing conditions. So how do we know this algorithm works? Well, I guess the proof is always in the pudding. Right, so firstly, we have tested in different localities around the world, and in particular, those areas that are prone to seasonal wildfires. In the first instance, it was tested along a section of right-of-way just north of Cape Town, South Africa. And in these blown-up images, you see the output of Prometeo, which correlates to dried-out Port Jackson trees, a tree species that typically has a high fuel load, which was also confirmed to have been present following ground truthing. Secondly, the algorithm was tested in the Napa Valley area of California. It's important to note that with Sentinel-2 satellite data, it has been capturing, or the satellite itself has been capturing images from around the world since June 2015. And so to test and validate the results, we accessed the archive and processed not only the satellite data captured on the 29th of September 2018, a week before a known fire event took place over the same area, but also we included the weather data covering the same period. Results were then compared to what was eventually burnt on the 8th of October 2018. This resulted in a 92% burn match between the vegetated areas deemed to be high fire risk with that of the actual burnt areas. Further testing was also undertaken in Victoria, in Australia, in February of 2019, and applying the same approach and comparing areas flagged as high vegetation fire risk with that of actual burnt areas, again showed a high correlation of more than 90%. So we're nearing the end of my presentation, but before I conclude, I'd like to end off with two summary slides. So what I've set out to achieve through this presentation really is to explain and demonstrate how, by using geospatial technologies combined with domain expertise, we at Hexagon are positioning ourselves to provide what we refer to as smart monitoring solutions to address some of the challenges specific to the electricity supply industry, especially with regards to the growing threat of wildfires. These include providing reliable as well as continuous vegetation condition monitoring along power line corridors, coupled with tools to evaluate these conditions, as well as tools that can allow decision makers to act to mitigate the threat of wildfires through improved vegetation management practices. The end result, we believe, can help to maintain power companies, can help power companies to maintain the integrity of their networks, leading to improved service delivery and public relations. These solutions we see as aiding and augmenting existing wildfire mitigation programs, which can ultimately serve to reduce cost as well as liability exposure. And finally, whilst what I've presented is focused on the electricity supply industry, we do also see applications in other industries, including environmental management, insurance and property management, agricultural monitoring, disaster risk reduction, as well as civil protection, where this solution can be used for pre-fire and post-fire planning, fire scar mapping, environmental monitoring, fire risk detection and planning, fire prevention planning, and preparedness planning. And so with that, I'd like to thank you for your attention, and I would now like to hand back to Barbary, who I understand has a survey question, which will then be displayed before we go to Q&A.
Absolutely. So thank you so much, Dean. It's fascinating what the science and technology can do together. So a quick question for everyone. Do you think that such a service will help you to protect your infrastructure from fire? So we'll give everyone just a moment to answer that question. While they're answering, though, let's take a couple of questions here. First for you, Dean, are all the applications that you showed developed using the MAP Enterprise platform?
Well, the quick answer is yes. Maybe I should just elaborate a little bit further, even though I've alluded to, hopefully to some extent, during the presentation. But so MAP Enterprise really is our core geospatial platform. And the way I like to think about it is it's a geospatial Lego box. So it gives you the Lego pieces from which you can then design, build, and I emphasize the word here, configuration or configure, because it's designed more for configuration rather than development, as well as to deploy what we call lightweight applications to cater for different users across large organizations. So in the end, it's an enterprise geospatial platform. And I think during the presentation, I provided some examples of the different types of applications that we can configure, such as the rich client application, for the manager to be able to assign tasks to field crews. But essentially what they have is access to a lightweight desktop GIS, if you like, which is combined with a workflow management component. And then we can build other applications such as the dashboard that you saw earlier with dynamic 3D map display, coupled with widgets that provide business intelligence. And then obviously the mobile application, which, as I said, is platform agnostic. And all that capability is possible through the platform. And that's essentially what we've done is we've taken that platform and configured it to establish a smart monitoring solution specific to corridor monitoring for the electricity supply industry and really to support their vegetation management practices. One thing I should also highlight is that we have the spatial modeling component, which allows you to make those spatial recipes from which the Prometeo algorithm was developed. And again, all of that capability comes under the hood with Map Enterprise. So yes, all the applications can be built and configured through the platform.
Excellent. That's great news. Can this solution be delivered as a managed service offering?
Map Enterprise and the underlying technology is designed for both on-premise and let's say managed service deployment. And in fact, that's the original intention of our offering, is to provide a managed service offering, really to try to reduce the overheads for the utilities in terms of the IT overhead, having to deal with all the data and all the processing. So the plan and the intention really is to offer that as a managed service. And in essence, all we would really need for anybody interested would be a shapefile that represents the extent of the right-of-way. Mm-hmm. And everything in the background we would handle together with our partner Geodata Design if that Prometeo service offering was a requirement. But as I said, on-premise deployment is also possible.
Awesome. So in terms of satellite imagery, you referenced Sentinel-2, but does Prometeo, the algorithm, support a higher resolution imagery provided by other commercial satellite data vendors?
Again, quick answer is yes, even if right now it's being configured to support Sentinel-2. But there's no reason why we couldn't support, or we can't support, high resolution imagery coming from other data vendors, whether that be Digital Globe, Airbus, Planet, or others. So it is configurable in a sense. I guess, as I mentioned, the benefit of Sentinel is freely available data, which really drives down cost, and also the frequency at which it's captured. Which is quite beneficial, and obviously caters for the extensive networks that have to be monitored by many of these utilities. But again, yes, we could support other data vendors, no problem. But that would also be a discussion we would have in consultation with our partner Geodata Design if the Prometeo algorithm was of interest.
Wonderful. Well, Dean, we are out of time. Thank you for taking a couple of extra moments to answer some questions here. And I see we have even more that are coming in. So if you still have a question, quickly type that in and we'll get that shared with the team over at Hexagon. They're going to follow up with you. Appreciate everyone attending today. Remember that the webinar recording will be archived. You'll get an email with a link to view that along with the resource links and an attendance certificate. We appreciate your opinions on the survey on the way out. And thanks again to Dean for sharing his expertise and to Nele for her work behind the scenes. Have a great day. Tell a friend about Hexagon and Directions Magazine. Thanks, everybody.